Hello everyone, welcome back to my YouTube channel. Today we will continue our topic, that is laws of motion. This is the part 2 of the chapter. In the previous part we have learned about concept of relative motion, what is scalar quantity and vector quantity, what is difference between distance and displacement, speed and velocity. So let us continue this chapter. Let's start today's subtopic, that is acceleration. So acceleration is nothing but rate of change in velocity. Rate of change in velocity means velocity change upon time. It is also a vector quantity as velocity is vector quantity. So formula of acceleration becomes change in velocity upon time. Now change in velocity, there are two things: initial velocity and final velocity. If suppose initial velocity is u and in time t it changes to final velocity v, we can write acceleration is equal to final velocity minus initial velocity upon time. Whenever we say change in velocity, it is final minus initial, so that is nothing but change. So v minus u upon t. For example, you are driving a car. Initially what was the speed of your car? That is u. And after time t, what is the speed of your car? That is v. So we'll just subtract the final speed minus initial speed upon time. This will give acceleration of our car. I hope you understood this. Let us discuss about types of acceleration. If the velocity of an object changes during a certain time period, it is said to have an accelerated motion. An object in motion can have two types of acceleration. First is uniform acceleration. If the velocity changes by equal amount in equal interval of time, then we say that it is an uniform acceleration. But if the velocity changes unequal amount in equal interval of time, the object is said to be non-uniform acceleration. Let us now discuss about kinds of acceleration. So there are basically three kinds of acceleration. One is positive acceleration, other is negative acceleration, and third one is zero acceleration. So when the velocity of object goes on increasing, it is said to have a positive acceleration. When the velocity is decreasing, then it has a negative acceleration. And when the velocity does not change, then it has a zero acceleration. In zero acceleration, please note that velocity of object does not change. It is does not change. Zero acceleration doesn't mean that the velocity of object is zero. It is not changing. Means the initial velocity and the final velocity are both same. Then it is a zero acceleration. So negative acceleration is also known as retardation or deceleration. So there are three words for negative acceleration. One is retardation, one is deceleration, and negative acceleration. So when the velocity decreases, it is negative. When it increases, it is positive acceleration. When it does not change, it is zero acceleration. I hope you understood what are the kinds of acceleration. Let us move ahead. Let us solve this exercise which is given in your textbook. So we need to match the first column with appropriate entries in the second and third columns, and we have to fill the table. So let us see here: negative acceleration, positive acceleration, zero acceleration. So column 2 we have definitions of them. The velocity of object remains constant. So where it remains constant? It remains constant in zero acceleration. So we'll mark zero acceleration to the velocity object remains constant. Velocity object decreases in negative acceleration, and it increases in positive acceleration. Now column 3 are the examples of negative, positive and zero acceleration. Let us read the first option. A car initially at rest. So it is mentioned initially at rest, means the speed of the car at initially is 0, reaches a velocity of 50 in 10 seconds. So after a time 10 seconds it reaches 50. From 0 it reaches to 50, means the velocity is increased. So this comes under positive acceleration. So I am writing here positive. A vehicle is moving with velocity of 25 meter per second. Now here they have not given us the initial velocity and final velocity. They are telling us the vehicle is moving with a constant speed, that is 25 meter per second. So this will come under zero acceleration. And the last, the vehicle moving with velocity of 10 meter per second stops after 5 seconds. Now here see the difference. Here they have told that the vehicle is moving with 10 meter per second, but after 5 seconds it gets stopped. Means the final velocity will be 0, and here the initial velocity is 10. So from 10 meter per second to 0 meter per second, the velocity has been decreased. So this is nothing but negative acceleration. So I hope you understood what is negative acceleration, positive acceleration and zero acceleration. Now let us understand how to plot a graph. After learning what is distance, displacement, speed, velocity and acceleration, now we will learn how to plot graph. The first graph is of distance versus time graph for uniform motion. Uniform motion is that motion of an object where the object covers equal distance in equal interval of times. So when an object in uniform motion covers equal distance in equal time intervals, the graph between distance and time is a straight line. So let us plot one graph and let us observe the nature of the graph. So this is an example from your textbook. Here they have given us the data in the table, time and distance. So first column is time and second column is the distance, and we have to plot a graph of distance versus time, where time is in x-axis and distance is on y-axis. So let us start plotting the graph. So as you can see here, when the time was 0 seconds, the distance was 0 meters. When the time is 10 seconds, the distance is 15 meters. So here is time 10 seconds. So 15 meter will lie somewhere here. So I am marking here 15 meter. I marked it with a red dot. Then after 20 seconds the distance covered was 30 meters. So after 20 seconds the distance was 30 meters, which is somewhere here. Similarly after 30 seconds the distance was 45 meter, so which is somewhere here. After 40 seconds the distance was 60 meter, which is somewhere here. After 50 seconds the distance was 75 meter, so 75 meter comes here. And after 60 seconds the distance was 90 meters, so 80, 100, so in between we have 90, and so on. You can plot it. Now you can see the when I join these dots, I can see a straight line. Okay, so this is the nature of the graph. So whenever a car is traveling in uniform motion means covering the same distance at equal intervals of time. So you can see here from 0 to 10 seconds the distance covered was 15. So for 10 seconds the car traveled 15 meters. Again from 10 to 20, what is the difference? From 10 to 20 the difference is again 10 seconds, and the car travel again, if you subtract 30 minus 15, again extra 15 meters it travel. Again from 20 to 30, again the time interval is 10 seconds, and again the car travel 30 to 45. So you subtract 45 minus 30, again it is 15. So you can see in the data, after every 10 seconds the car is traveling 15 meters. So that's why our graph is a straight line. So the nature of distance time graph for uniform motion is a straight line. Now one interesting thing I want to tell you, if you find the slope of this graph. Slope means change in y coordinate upon change in x coordinate. For example, I have constructed here one triangle. Now this is our y coordinate and this is x coordinate. This is y coordinate and this is x coordinate. If I take the ratio of y coordinate upon x coordinate, we'll get the slope of the graph. And slope of distance and time graph is nothing but velocity or speed, you can say, because on y-axis we have distance and on x-axis we have time. So distance upon time will give us speed. So slope of distance versus time graph is nothing but speed. So here for any interval you can check the speed. If you check the slope of this interval, every time you will get the same speed because this graph is of uniform motion. So the speed will remain constant. I hope you understood how to plot a graph of distance versus time and what is the application of this graph, what is the nature of the graph, and how we can find the speed of the vehicle using the slope of the graph. Now let us discuss about the distance time graph for non-uniform motion. So when a body performs non-uniform motion, when it moves in unequal distance in equal interval of time. Here also we have given a data of time and distance when a bus is traveling, and the interval of time is equal, that is of 5 seconds as you can see in the data, and but the distance is not equal. So we need to plot a graph here to understand the nature of the graph. So we'll just plot a rough graph to understand the nature. So on x-axis we'll have time, and on y-axis we'll have distance. So 0, 5, 10, 15, 20, 25, and so on. We'll just put 4 5 readings and observe the nature. Here 10, 20, 30, 40. So if you can observe, when the time was 0 second, the distance is 0 meter. For 5 second, the distance is 7 meter. So 7 meter will lie somewhere here. 10 second, the distance is 12. So it will lie somewhere here. This is just a rough graph. For 15 seconds is 20. For 20 seconds is 30. For 25 it is 41. Now as you can see, when I connect these markings, so you can see there is not a no uniformity in the graph. So we can say the nature of graph is not a straight line. Okay, since the time intervals are same, but the distance covered between the time intervals is different. So we will not see here a straight line graph. It is not a straight line graph. So here one question is asked: does the graph show direct proportionality between distance and time? So the answer to this question will be no. There is no direct proportionality between distance and time, because for same time interval different distances are covered. When the car is, for first 5 seconds he has covered 7 meters, for next 5 seconds it has covered 5 meters, next 5 seconds it has covered 8 meters. You need to just subtract it. So the distance versus time graph for uniform motion is a straight line, while the distance versus time graph for non-uniform motion is not a straight line. This is what a conclusion we can draw. So here we have summary for distance versus time graphs for different cases. First case is for stationary body. If the body is stationary, it is not moving. Though the time is running, but the distance will be same. So this graph is parallel to x-axis. Second case is for uniform motion. If a body is covering equal distance in equal interval of time, the graph plotted will be a straight line graph. For non-uniform motion, with when speed increases and when speed decreases. Now for non-uniform motion, the distance covered is unequal for equal interval of time. If the speed increases, you will see this kind of graph which is moving upwards, going upwards. If the speed decreases, the graph will come downwards. So these are the four graphs, and from these four graphs we can make a conclusion that for uniform motion the graph is a straight line, for non-uniform motion the graph is not a straight line. Let us have a discussion on second graph, that is velocity versus time graph for uniform velocity. Uniform velocity means for a particular interval of time the speed or the velocity of object remains same. Here is one example. A train is moving with a uniform velocity of 60 km per hour for 5 hours. So for 5 hours the train was moving with same speed, same velocity, that is 60 km per hour. So the velocity time graph for this uniform motion is shown in the figure. Okay, so this is our velocity versus time graph. They have shown for the first hour, second hour, third hour, fourth hour, fifth hour. So here you can see 1 hour, 2 hours, 3 hours, 4 hours, 5 hours. So you can see the graph, the velocity of the train is same, that is 60 km per hour. Now there are two questions asked. With the help of the graph, how will you determine the distance covered by train between 2 and 4th hour? So between this 2 hour and 4 hours, between these two time intervals, what is the distance covered by the train, this we have to determine. Okay, now what is the graph? It is velocity versus time. Now do we have any relation between velocity, time and distance? So yes, we have velocity is equal to displacement, that is distance upon time. So if I want to find the distance, what will be my formula? Distance is equal to velocity into time, velocity multiplied by time. So we will use this formula to find the distance. Now for that we need velocity and we need time. Now they have told us to find the distance covered by train between 2 and 4 hours. So this is what they have told us. So the region is this region, right? So they have marked it with the dotted black spots. Now if you observe this graph carefully, distance is nothing but velocity into time. This is our time on x-axis, velocity on y-axis. We just need to take the area of this quadrilateral or area of this rectangle ABCD, which I am shading here. So you want this area of this rectangle. What is the area of rectangle? Length into breadth. So what is the length here? Length is the x-axis, breadth is the y-axis. Now from that x-axis, which interval we want? Between 2 and 4. So between 2 and 4, what is the length? It's 2 hours. Difference 4 minus 2 is 2. And what is the velocity? It is 60. So we'll just multiply 60 multiply by 2, that will give 120. So I can say that the distance covered by train between 2 and 4 hours is 120 kilometer, because the unit is given here kilometer per hour, so distance is kilometer. So as we said, in distance versus time graph, the slope gives us the speed. Similarly, in velocity versus time graph, the area of the curve or the area of the graph gives us the distance. Second question, is there a relation between distance covered by train between 2 and 4 hours and area of particular quadrangle in the graph? What is the acceleration of the train? Okay, there are two questions asked. Is there a relation between this distance and the area? Yes. The area of particular quadrangle in the graph, here in this case it is rectangle. The area is nothing but the distance covered. So you can say that the distance covered by the train between 2 and 4 hours is nothing but equal to area of the quadrangle in the graph. Second question asked is, what is the acceleration of the train? Now what is the acceleration? Change in velocity upon time. Do you see here any change in velocity? See, when the time was 0, the velocity was 60. When the time is 5 hours, then also the velocity is 60. So here the velocity, initial velocity and the final velocity are both same. So acceleration will be 0. So this is an example of 0 acceleration. I hope you understood how to plot a graph of velocity versus time, and what is the nature of that graph, and what is the application of that graph. Application is this, that the area of velocity versus time graph gives us distance, and with the help of that we can also find acceleration. So this is how a velocity versus time graph is plotted for uniform velocity. Now we will discuss the velocity versus time graph for uniform acceleration. Changes in velocity of car in specific time intervals are given in the following table. Now uniform acceleration. Uniform acceleration means the change in velocity for equal interval of times is same. For example, between 0 to 5 seconds, the change in velocity is same. Between 5 to 10 seconds, the change in velocity is same. Then it is known as uniform acceleration. As you can see from the data, from 0 to 5 seconds, velocity is 8. Again from 5 to 10 means next 5 seconds the velocity is again 8 meter per second. It is 16. So 16 minus 8 will give 8. We have to find the difference. Again next 5 seconds at 10 to 15, for next 5 seconds again the velocity is increased by 8, means after equal interval of time change in velocity is also equal. That's why it is known as uniform acceleration. And when we plot the graph of velocity versus time for uniform acceleration, we get a straight line graph, as we got in distance versus time for uniform motion. Similarly, the velocity versus time graph for uniform acceleration is also straight line graph. Let us have a summary of this velocity versus time graphs. So here we have four cases. The first case is constant speed. If the body is moving with a constant speed, there is no change in the velocity. So therefore, the graph of velocity versus time will be parallel to x-axis. The second case is that uniform acceleration. Uniform acceleration means for equal interval of time, the velocity change will be equal. For first 5 seconds, if the change in velocity is 8 meter per second, for the next 5 seconds it will be also 8 meter per second. So when we plot the graph of velocity versus time for uniform acceleration, we get a straight line graph. Similarly, for non-uniform acceleration, there are two graphs. One is non-uniform acceleration, non-uniform retardation. Let us understand first non-uniform acceleration. Non-uniform acceleration means for equal interval of time, the change in velocity is different. For example, for first 5 seconds, the change in velocity is 8 meter per second. For next 5 seconds, the change in velocity may be 6 meter per second, 10 meter per second. So here you will not get a straight line, here you will get a curved line. And for retardation, now what is the difference between non-uniform acceleration and retardation? In non-uniform acceleration, now you can see when the time was 0, the velocity was also 0 meter per second, and with increasing time the velocity also got increases. But in retardation, when the time was 0, the velocity was maximum. The velocity was maximum, and with increasing in time, the velocity got decreased and finally it reached to 0 meter per second. So it is like in non-uniform acceleration, the body is moving from rest, then it is moving with to a maximum velocity. But in retardation, the body is already at maximum velocity and it is coming to rest. I hope you understood these graphs of velocity versus time and also of distance versus time. So here we end our today's session, and I hope you found this video interesting. Do like, share and subscribe our channel. We'll meet in the next video and we'll continue the chapter. Thank you.